Hello friends, welcome to this video. So here we learn mainly about nuclear energy, what is nuclear energy and how it is obtained. About that we'll discuss. So you can see this graphical representation pie chart which shows various sources of energy. Okay, so oil, coal, gas, nuclear energy, then hydroelectric power, solar or wind energy. Others different sources of energies have been shown here. So as you can see, it's very clear that the major sources of energy are oil, coal, and gas, natural gas. Okay. So, nuclear energy constitutes about 6% of all the energies, all the power sources of the globe. Okay. So, but again, one thing that we have to understand is that we have to remember is that oil, coal, gas, nuclear sources, all of these are non-renewable sources of energy. Okay, whereas solar, wind, and the others, these are renewable sources of energy. But here we will, in this particular video, we will specifically talk about the nuclear energy. Okay, how nuclear power or how do we get nuclear energy? So nuclear energy is also a non-renewable source of energy. But is there any advantage of nuclear energy over other non-renewable resources? Okay, other non-renewable resources are oil, coal, and gas. Okay. So first of all, nuclear energy, it is a clean source of energy. Okay, it's clean. It does not do environment pollution. However, we'll also discuss about disadvantage later, like coal or oil. It doesn't create any environment pollution. But again, about the disadvantages, we'll talk later. Then one major advantage is that a huge amount of energy can be generated by nuclear reaction. Okay, so huge amount of energy. So huge amount of energy can be generated by a nuclear reaction as compared to other conventional sources like coal, oil, or gas. Okay. So for example, if we have 1 kg of uranium and 1 kg of, suppose 1 kg of coal, okay. So can you imagine how much energy we can get from 1 kg of coal? That is 10 to the power 14 joule. Sorry, 1 kg of uranium will give you around this much energy, 10 to the power 14 joule, whereas 1 kg of coal will give you about 10 to the power 7 joule of energy. Okay, so you can see the clear advantage of nuclear energy over coal or oil or gas. Okay, so now one major question arises. The question is, how do we get this nuclear energy? Or what's the source of nuclear energy? How you can produce this nuclear power? Okay, or from where do you get nuclear energy? So, in order to understand the source of nuclear energy, there is a phenomenon called nuclear fission. Okay, nuclear fission. We have to understand this phenomenon. Okay, so what is fission? Fission means breaking. Okay, breaking of a heavy nucleus into smaller, uh, smaller nuclei. Okay, smaller nuclei. So, how do you break a heavy nucleus into smaller nuclei? So, heavy nucleus into suppose a small nucleus 1 and a small nucleus 2. So, how do you break them? Okay, in order to break heavy unstable nuclear source like uranium. Okay, we'll come back to this uranium example after a while. But what are the, how do we break them? So we break them by sources like proton, neutron, or alpha particles, okay, like proton, neutron, or alpha particles are predominantly used to break such a heavy nucleus and to obtain such smaller nuclei. Okay, so how do you break them? So a nuclear reaction is performed or conducted. Suppose one very widely used source is uranium. Okay, uranium 235 92. Okay, so the mass number here of uranium is uranium 235 and atomic number is 92. So if this uranium is bombarded with neutron, okay, neutron symbol is this one. So what happens? Okay, so what happens is this uranium 235 is broken into two constituents. Okay, so okay, before they break, so we get one unstable state. Okay, unstable state is something like this. And what are the two constituents? The two constituents are generally barium. Okay, barium 144 56 plus krypton krypton 89 and 36 plus 3 and 10. Okay, so some this type of products we get. Okay, 56. Okay, so total it's the mass number here is 236, and here also uh, here also you will get mass number of 236, and here atomic number is 92, and here also you get atomic number of 92. So this type of reaction, so this way a heavy nucleus is broken. Okay, heavy nucleus like uranium 235 is broken by bombarding it with a neutron, and we get this as the products. Okay, so this resultant products are also radioactive, and stable products are obtained later by emission of beta particles. Okay, so this is an example of nuclear fission reaction. Okay, so we can simply call this a nuclear fission reaction. So in a such nuclear fission reaction, huge amount of energy is produced. Okay, huge amount of energy. So how much energy is produced? We will so huge amount of energy in such a reaction. That energy value is about we can say that it's close to 200 mega electron volt. Okay, so how this energy is produced, that we shall discuss in the next video, and how we get this much of energy, and how this energy is utilized in power generation, and so those things we'll discuss in the next video. So thank you very much for watching, and I will see you next time. Thank you.